Assalamualaikum and hi. So we continue back on frequency response design via lag compensator part 4. Okay, we refresh back from step number 6. We already locate the asymptote from step 5 at high cutoff frequency at this point. Okay, so this is the negative j omega pm prime, for example negative 26 dB at high cutoff frequency. So we locate with X symbol. For example, this one at this location at negative 24.5 dB at 0.06 dB. So in step 7, based on this location, based on this one, draw negative 20 dB per decade slope to 0 dB. Okay, so draw this negative 20 dB per decade until it crosses 0 dB value. So at 0 dB, the crossing point between this negative 20 dB per decade slope and 0 dB is actually your low cutoff frequency in radian per second, where this value is actually the pole compensator for lag compensator. So in this case, the PC and low cutoff frequency is 0.0038. So this is the diagram, how to draw the 0 dB slope. Okay, this is your asymptote, negative 26 dB. And then locate the location of negative 26 dB and high cutoff frequency. So draw the X symbol here. And from this point, you need to draw the negative 20 dB per decade, meaning that this one is 20 dB. This one is 1 decade. If this is omega HF, for 1 decade, you need to draw until 0.1 omega HF. Let's say this is 0.6, so this one must be 0.06. So this is the X length, while the Y length is negative 20 dB. That's why the slope must be like this, 20 dB, not like this. Okay, like this. And then you extend the slope until it crosses 0 dB. So this crossing is actually the low cutoff frequency. The crossing between the negative 20 dB slope with 0 dB line is actually the low cutoff frequency, where this is actually the PEC, the pole compensator of the lag compensator. Okay, next we continue on step number 6 to determine the K lag, the gain for lag compensator, which is equal to PEC lag divided by ZC lag. After we determine the lag gain, we can construct the lag compensator transfer function, which is equal to K lag multiplied with S plus ZC lag divided by S plus PEC lag, like this one. So this is to determine the KC, PC over ZC lag. So we construct the lag compensator transfer function, KC lag, this is ZC lag, and this is PC lag. And finally, if the question asks you to determine the compensated transfer function, you multiply the original open loop transfer function with the lag transfer function. So this is the compensated transfer function for the lag compensated system. So that's it for frequency response design via lag compensator. Thank you very much.